So moving into circular functions. Circular functions are your sine, cosine, and tangent functions and the applications that involve those types of functions. You will not have to worry about any of the reciprocal functions. Unfortunately, you'll never get an opportunity to learn about them unless you decide to pursue that on your own. So sine, cosine, tangent, those are the main ones. We're going to derive the unit circle, and we're going to solve some basic equations using the unit circle. We'll get to some more advanced ones on Wednesday, and I don't know, we'll see where we are on Wednesday to see if we go in applications by Friday. Okay? So, the unit circle has its center at the origin, 0, 0, inside of a Cartesian plane. Okay? It does have a radius with a length of 1. And the terminal side of any angle theta in standard position will meet the unit circle at a point that has the coordinates cosine theta, sine theta. Okay? Yes. I'm going to ask, have I gone over that? I haven't. Okay, so when you have an angle that's inside the unit circle, of course, its vertex is going to be at the origin. The initial side is the side that's always fixed to the positive x-axis, meaning that it will never move. It will never leave the positive x-axis side. Okay? The terminal side is the side that actually creates the angle. Okay? So in this particular picture, what you see here, this line right here will be considered your terminal side. Okay? Is the final side that creates the angle. So you can have terminal sides anywhere inside of the unit circle. Okay? And so the point in which that terminal side intersects the unit circle, that point is not labeled, 2, 3, or -5, -6, or whatever. It is cosine of your angle, sine of your angle. So you'll either know or be able to find out exactly what that angle is. For example, that angle could be 30 degrees. Okay? So then that point, that coordinate where it intersects the x-axis, intersects the unit circle, will be the cosine of 30 degrees, comma, the sine of 30 degrees, which you already know what those are based off of our do now. The cosine of 30 degrees is the square root of 3 over 2. And the sine of 30 degrees is 1/2. So technically that's the ordered pair on that point of the unit circle. Tangent. We talked about this back in trigonometry. I said, I'm going to go over it now because we're going to be using it later. Here's the later. Tangent, to refresh your memory, is sine theta over the cosine of theta. Okay. So that would be the sine of 30 degrees divided by the cosine of 30 degrees. And you would simplify that. But the main thing is that the unit circle has a radius of 1. And when you have an angle inside the unit circle, it is said to be in standard position. Again, the initial side, one side is fixed to the x-axis, the other side is the one that creates the angle.
So the terminal side is
Well, they'll both would technically be a radii, but one will always be on the x-axis. That's always the starting point, and from there you create the angle. Now, when you have an angle in standard position, the angle theta is positive if it opens in a counterclockwise direction. So if it's a counterclockwise direction, the angle is positive. So again, the initial side is on the positive x-axis. The other side, the terminal side, is somewhere inside of your unit circle. So from that initial side going counterclockwise, that creates the positive angle, hence that 135 that's in the picture. You create a negative angle if it opens in a clockwise direction. So if it goes in the clockwise direction, that is a negative angle. In this case, you have negative 225 degrees. How many degrees are in a circle?
360.
360. So if you take away the negative, those do add up to be 360 degrees. Okay, so they're, if anything, they're complements of each other. Okay? And wherever that terminal side lies inside of the unit circle, don't forget these are quadrants. Okay, this is the first quadrant, this is the second, this is the third, and this is the fourth. So the same rules that would apply to any point that's in those quadrants applies here with your sine, cosine, and tangent of a particular angle. In the first quadrant, sine, cosine, and tangent are all positive. In the second quadrant, only sine is positive, cosine and tangent are negative. In the third quadrant, sine and cosine are negative, tangent is positive. And in the fourth quadrant, cosine is the only one that's positive, sine and tangent are negative. All students take calculus. I'll wait for you to remember which ones are positive. A for all, S for sine, T for tangent, and C for cosine. So this is used again when in the creation of the unit circle. Anytime you're trying to solve a trigonometric equation that deals with things outside of right triangles. And yeah. Any questions? Then let's do this. Okay? You don't have to write down anything from this page. I'm just trying to refresh your memory, like I did for your do now, that we're going to basically pull all of our information from our special right triangles to create our unit circle. Okay? So I did it over here on the whiteboard, so it could be here nice and pretty for you. So that way you don't have to keep flipping back. Okay? On your paper, draw a circle. Okay? And I would suggest go ahead, if you are halfway through, you might just go ahead and just flip on the back. Just go ahead and flip on the back. Okay? On the back, draw a nice big circle. Draw an X and a Y axis. And in each one of the quadrants, you should have 3 dots. The lines are optional. They really are optional. So, remember, the initial side of any angle is always fixed to the positive x-axis. So if you have your initial side and your terminal side both on your positive x-axis, that is a degree of 0. And actually, let me put that on top. Of 0 degrees. Okay? And then from there, you're hitting the main special angles from your special right triangle. Okay? Your next smallest acute angle would be what? Say again. 30, followed by, and then of course, if your terminal side was on the positive y-axis, that would be how many degrees? 90 degrees. Very good. And the other angles along your unit circle, they correspond in the same type of fashion. Okay? Let's go ahead and let's hit the rest of these, okay? Straight across on your negative x-axis, that's 180 degrees. Okay? It's half of a circle. And then the point before, so this point right here, would be 30 degrees away from 180, which is what? 150. This point would be 45 degrees away from 180, which would be 135. And then this top point would be 60 degrees away from 180, which would be what? 120. Now, yes, there's other ways that you could have created those angles and everything like that, but I'm harping on the fact that everything is in retrospect to the x-axis. Okay? Everything's in retrospect to the x-axis. As I keep going, again, I'm 30 degrees away from 180 as I continue along my circle. What is that? 210. This next point is 45 more. 225. And this last point before we hit that negative y-axis is 60 degrees. 240. Okay? When I've gone 3/4 of a circle, I've gone how many degrees? 270 degrees. Very good. And then I continue on from there. Now, when I've gone a full circle, how many degrees is that? 360. So you know, technically at 0 degrees, if you've gone a full rotation, a full one time around, that's 360 degrees. So what's 30 degrees away from 360 going backwards?
330.
330. 45.
350.
And 60.
300.
300. And those are all the degrees in your unit circle. Coming back? It never left?
No, I kicked it out.
You kicked it out? Well, I need you to go apologize and get it back, okay? All right. Let's do the the unit circle is comprised of degrees, radians, and ordered pairs. We'll save the that for later. Okay? Let's do the ordered pairs. Now, the radius of the unit circle is what again? It's 1. So if you have a point here that's on the x-axis is the full radius of the circle, this ordered pair is, say it again, 1, 0. Very good. 1, 0. Your x-coordinate is 1. Your y-coordinate is 0 because you didn't go up or down any. Okay? What about at 90 degrees? What's the ordered pair there?
0, 1.
It'll be 0, 1 because you are up 1 unit on your unit circle, but you didn't go out any for your x. What about over here at 180?
-1,
-1, 0. 270?
0,
0, -1, and then 360 would be the exact same ordered pair as 0 degrees. Okay, those are the easy ones. Let's get to the juice. Okay, 30 degrees. Now, what I talked about before, on a unit circle, when you have that terminal side intersecting the unit circle, that point is cosine theta, sine theta. So, on your unit circle, at 30 degrees, the x-coordinate would be the cosine of 30 degrees. What is the cosine of 30 degrees?
square root of 2.
And then the y-coordinate would be the sine of 30 degrees. It'd be 1/2. You see how you use those special right triangles there, here? Again, it goes cosine, then sine. Easy way to remember that, C comes before S in the alphabet, just like X comes before Y in the alphabet, okay? So for 45, to find the x-coordinate is the cosine of 45 degrees, which is
Root 2 over 2.
√2 over 2. And then the sine of 45 degrees would be
Root 2 over 2.
√2 over 2 as well. And the last one for the first quadrant, again, it goes, what's the order?
Cosine, sine.
Cosine, then sine. What's the cosine of 60 degrees?
1/2.
And what's the sine?
Root 3.
And you have your first quadrant's ordered pairs. Now, once you know the first quadrant, you have the other quadrants, okay? There was a reason why I asked you when it came to filling in the rest of the degrees. You know, this point was 30 degrees away. This point was 45. This point was 60 degrees away. That's because they shared the same ordered pairs as 30, 45, and 60 in the first quadrant. It's just that because you're in the second quadrant, the x's are negative. The cosine is negative, and sine is positive. All students, sine is positive. So 120's ordered pairs is going to be what?
-1/2. 3 over 2.
Same ordered pairs, it's just that your x's are negative. What about at 135? Very good. And at 150? There we go. The exact same ordered pairs, you're just in the second quadrant, so your x's have to be negative. Your cosine has to be negative. What about in your third quadrant? Which one's negative? They both are. So it shares the exact same ordered pairs, except both of them are going to be negative. 210 matches up to which one of those?
6.
30. It's 30 degrees away from that x-axis. So what's the ordered pair?
-√3 over 2.
You see how it's going? Can you guys finish up the rest of the circle? All right, finish up the rest of the circle. As you finish up the third quadrant, the fourth quadrant, which one is, the y is what? Negative. So that means that sine is negative. So it has the same ordered pairs, but the y value, the sine value, is negative. As you're finishing up. Okay, ordered pairs, 225, what you got?
-√2 over 2.
Negative √2 over 2.
-√2 over 2.
Negative √2 over 2. What about 240?
-1/2. -3 over 2.
Good stuff. All right, going over here. 300 is 60 degrees away from 360, so it corresponds with the ordered pairs of 60 degrees. So what is 300?
1/2. -√3 over 2.
Very good. So the y's are negative. The sign is negative. 315.
Root 2 over 2. Negative root 2 over 2.
Wonderful. And 330.
Root 3 over 2. Negative 1.
Yes?
Yes.
Wonderful. Now for these good old radians. Yes, there's a pattern. Yes, there's some type of way for you to remember them. And to be honest, different students learn it different ways, okay? I probably do it a different way than any of y'all have, okay? Your fallback, just in case, is you can always use the conversion, which we went over back in trigonometry unit. How do you convert from degrees to radians? Which one is it? You multiply by pi over 180, okay? You multiply your degrees by pi over 180. So, go ahead and find my radians for my unit circle. All right, so let's get my radians. Now again, the multiplying by pi over 180 is just like a fallback just in case you happen to forget one of them, okay, or you're like unsure, you're uncertain. That's always a fallback, but you cannot do that for all of your degrees, especially when you're being timed on a unit circle quiz, okay, or you're being timed on a test. I will never ask you on a test to write out the unit circle, okay, but you are going to need to be able to use the unit circle to solve equations, graphs, all types of different things, okay? So 0 degrees is what radian? 0 or 0 pi. Do not forget about that one. That is one of like the most forgotten ones. Either that or the one that corresponds to 360 degrees. What's 360 degrees?
2 pi.
2 pi. Okay? 30 degrees. Keep going.
Pi over 4. Pi over 3. Pi over 2. 2 pi over 3. 3 pi over 4. 5 pi over 6.
Y'all get a little quiet.
Pi.
Get a little quiet.
7 pi over 6. 5 pi over 4. 4 pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. 11 pi over 6.
And 2 pi. And that is the unit circle. All radians, degrees, and ordered pairs, different patterns and things of the like that, yes, you will need to know for your unit circle quiz that I'm expecting you to be able to do in 4 minutes. Now, if you notice, when we were creating this unit circle, we were going in the counterclockwise direction, hence why all the angles were positive, okay? These same ordered pairs, these same ordered pairs correspond to the angles when you're going in the negative direction, okay? So if I went here to this angle, right there, this angle right here, this isn't 210 degrees because I've gone in the clockwise direction. How many degrees would that be? Negative what? It'll be negative 150. Okay? Now, granted, the ordered pair would still be the same, but the degree would not be. And hence, the ordered pair would not be either. What would be the ordered, the ordered pair would be the same, but the radian wouldn't be the same. What would be the radian of negative 150? Negative 5 pi over 6, okay? So this angle, it would not be 7 pi over 6. It would not be 210 degrees. It would be a negative 150 degrees. We basically gone that same distance that we would have gone in the counterclockwise direction. We just went in the clockwise direction, okay? So being able to recognize that, okay? What if we went, to this angle right here? That would be negative 330 degrees, or as what, as a radian?
Negative 11 pi over 6.
But the ordered pair would still be the same because you're still in the first quadrant. So your ordered pair would still be positive, and it will still be square root of 3 over 2 and 1/2. We're okay on that?
Yes.
Okay. Because you'll need that when we're going into solving equations, okay? When you're solving equations, you need to know three things. First thing is, of course, your unit circle, because without it, you're not going to be able to solve these problems, okay? But the other two things that you need to know is, one, is the angle in degrees or radians, because your answer needs to be in degrees or radians. And then what is the domain? Okay? Because it'll say, find the value of x or find the value of theta between one angle and another angle. And you want to make sure that you provide all the solutions in that respective domain. So 2 things you need to be aware of. Now, granted, there are indefinitely many values for a variable when you're solving a trigonometric equation. Because sine, cosine, and tangent, they are sinusoidal functions. They are functions that are continuous from negative infinity to positive infinity. So there's infinitely many solutions to any trigonometric equation. But it's the domain that they restrict you to that will help you in providing just maybe 2 answers or 3 answers or 1 answer. Okay? So you always want to be aware of the domain so you make sure you provide all the answers within that domain. All right, we're going to solve this equation. Cosine x equals negative square root 2 over 2. X is in between negative 2 pi and positive 2 pi inclusive. Now, we are looking for x. Is x in degrees or radians? Is that radians or degrees? It's radians. So that means your solutions should be your pi's over 6's and your 7 pi over 4's and things like that. Okay, so all your solutions. And here, this problem is basically asking us, okay, where's cosine a negative square root of 2 over 2 on that particular domain? Okay, now using our unit circle goes from 0 to 2 pi. So we can provide all the solutions of where cosine is equal to a negative square root of 2 over 2 from 0 to 2 pi, and then we just need to go clockwise to get the ones from 0 to negative 2 pi. Okay? So if you look at your unit circle, remember cosine is which coordinate, x or y? X. So really and truly, it's actually asking where is your x value a negative square root 2 over 2? The second and third quadrant. Which radian in the second quadrant is your x value a negative square root 2 over 2?
3 pi over 4.
It's that one that's smack dab in the middle. It's your 3 pi over 4. And what about in your third quadrant? Which one is it? 5 pi over 4. So x is equal to 3 pi over 4, 5 pi over 4, and those are your solutions from 0 to 2 pi. Did everybody catch that? But we got to go all the way to negative 2 pi, so that means we need to go in the clockwise direction. Now remember, the order pairs stay the same when you're going in the clockwise direction. So those same spots that you pulled for 3 pi over 4 and 5 pi over 4, those are still the same spots you need to go to when you're going in the clockwise direction. You just need the angle that corresponds to it in the clockwise direction. So 3 pi over 4 in the clockwise direction would correspond to negative what? Negative 5 pi over 4. Because you've gone negative pi over 2, negative pi, and then you need that one that's in between negative pi and negative 3 pi over 2. What about this one here? What's this negative value? Negative 3 pi over 4. Before anybody asks, no, they will not be the exact same. They will not be the flip-flops of them. It just happens to be for this particular one. So negative 3 pi over 4 and negative 5 pi over 4. And those are your solutions to this equation. Yes, this is a simple one. Baby steps. Okay? Let's look at the next one. Tangent x equals the square root of 3. This time we're going between 0 and 360 degrees. So that means all of my solutions should be written how? in degrees. Okay, so always make sure you look at your domain so you provide the correct solutions. Okay? So, tangent. Ugh. Tangent is not, like, you can't just look at your unit circle and pull out tangent, okay? You only have sine and cosine on your unit circle. The tangent is what? It's sine over cosine. So you have to figure out, okay, which combination of ordered pairs is that when I do the sine value over the cosine value and simplify it, it's going to give me the square root of 3. And yes, one is already on the board from your do now. Where was that at? What angle? 60 degrees, okay? So, if you didn't know that, yes, you would have to go through the process of saying, okay, the sine at 60 degrees, the y value at 60 degrees is the square root of 3 over 2. The cosine of 60 degrees, the x-coordinate at 60 degrees is 1/2. When you have a fraction within a fraction, what do you have to do? Multiply by the reciprocal. What happens with the 2's? So then you just left with the square root of 3 over 1, which is the square root of 3. So then that is the combination you would want, where your sine is the square root of 3 over 2, and your cosine is 1/2. But it's not just at 60 degrees where tangent's a positive square root of 3. Where else is tangent positive in your unit circle? 240. It's the one that's in the third quadrant where tangent is positive, and that is 240. Have I satisfied my domain? Have I provided all the solutions between 0 and 360 that have a positive square root of 3? Tangent does. Then those are your solutions. Questions? Is it going to get harder?
No, I'm just wondering how many questions.
It depends. It really does. Okay? All right. Grab a marker and a felt. We're going to do some on your desk. All right, so let's take a look at this one because this one's a little bit different. And mostly it's different because of the domain. Okay? You're going from negative 180 to 270 degrees. So your answers need to be in degrees. And on top of that, you need to go beyond 360 degrees. How far beyond 360 degrees do you need to go? And so that'll be another 360, okay? So I'm going from technically negative 180, which is here, to 0, then a positive 180, to 360, then to a 540, to a 720. So I'm technically starting, I don't know, I can't really draw because then it'll be kind of not proper, but, you know, I have to go this way, and then I have to go around. Okay? So I got to hit all of them. Where is cosine 1? At what point on our unit circle is cosine 1?
0.
At 0. Is it only there?
Yeah, only that.
Only that one point. So technically, you have all of them, since it was one of the quadrantal angles. It wasn't plus or minus 1, it was just a positive 1. So then your solutions were?
0, 360, 720.
Now, if it did say cosine theta equal plus or minus 1, you would have all 6 of them that I've written down here. Okay? Questions?